we have two levels of DR. We have intra and intercity DR inside of our cloud. And the first is we have systems, let's say in data center 1 in Columbus. And then we have systems in data center 2 in Columbus. So between these data centers, we have a high-speed DWDM ring, which is dense wave divisional multiplexing. It allows us to take 40 to 80 wavelengths and put them onto a single pair of fiber. So this plus our own fiber backbone in and around the city allow us to high-speed interconnect our data centers together with very low latency. What we do is we attach our SAN to that network in both locations, and we do what's called a synchronous replication between the two. Every time that a change is written to here, the change is written here. So at all points, the data is consistent between the two. And then we use what we talked about earlier, the VMware, either fault tolerance or HA, and we trick VM into thinking that we have a single set of shared disk between the two environments. They do not know that there's a SAN here and a SAN here. All they know is they have network connectivity to each other. They think they're in the same data center, and the disk is in the same data center. If we lose this data center, this VM picks up against that disk instantaneously or within 3 minutes, depending on the fault tolerance mechanism we chose, and that customer is up and going. This is inside the same city. Across cities gets a little bit trickier. So we have, again, a SAN and a whole bunch of compute. And then over here, say in New York, we have a SAN and a whole bunch of compute. Right? And we're replicating this back and forth using async. And we say like we're within a minute or 30 seconds or however long we want of being synchronized with each other. And you create what you call journal checkpoints. At this point in time, I'm consistent. At the next point in time, I'm consistent. You create those checkpoints. And you're replicating back and forth. Then we use a product called Site Recovery Manager between the two, where you have a VM here. The VM is actually running off of the SAN. It's replicated across, actually to the other SAN up here. This compute's attached to it. And you're replicating, and you have these checkpoints that are occurring. You lose this site. You're now down. SRM brings up your VM image over here against one of the checkpoints. So it's not as real time as being in the same city, but it allows you to actually plop it down in a totally different geography. We then use another technology called OTV, which is over-the-top virtualization. One of the big problems in cloud and in all of the VMware products in general is that when you pick up a server living in Columbus and drop it in New York, you're going to have different layer 3 and different layer 2 domains. That's how networks are built. But when you plop it down, now this server either has to change its IP address or change its layer 2 personality, and all of your applications break. Everything starts to break down. Well, traditionally, network architects haven't wanted to extend layer 2 from city to city because the protocols don't work. So now what they've come out with is OTV, Cisco protocols, Nexus on one side, Nexus on the other, and OTV allows you to span layer 2 between the actual sites. So now you can mimic up your layer 2 and layer 3 from here to here, and you can actually pick up and drop the whole thing over there instantaneously. So it allows you to truly and seamlessly pick up your compute and redrop it into a new data center and have it resume workload. These types of technologies are going to allow us to do follow the sun type activities where we can actually have a workforce as they're working through the day, have all their load located next to them, and then as the load moves to the Midwest from England, let's say, now the workday starts in the Midwest, move all the compute over to the Midwest, and as we move to the West Coast, pick it up and drop it in LA, let them get their work done, and then do the whole thing again. You can also do it to save power, where you can move it so where it's always nighttime and the cooling costs are lower. And there's all kinds of different applications, but what we see most is customers wanting to be able to keep their applications and their computing closely home to them for better application response time. There's been a whole lot of it in the financial markets in New York where they're doing these statistical trades in and out of a position hundreds of times a second. They have to have quick access to their applications to be able to execute that. So our systems are built to be able to accommodate that, give the DR functionality, be able to move things between data centers depending on the time of the day, depending on the workload, depending on the requirement.